In this lesson, we're going to have a look at how I created the fork blade and the wishbone. Let's open the fork blade first. The fork blade only has a few features, and only one of them is interesting. In this case, we started with a thin feature extrude to create the hollow main leg of the fork leg, and then created a plane that was intended to be the end of the transition between the circular shape and the rectangular shape. On the new plane was sketched a rectangle. The loft or the boundary are perfect features to choose to transition between one shape and another. For this particular feature, the settings were fairly simple. Let's take a look at it. The two profiles were chosen, and in this case, I used end constraints. The constraints on both ends are normal to profile. Let's take a look at what these would look like if they used the none constraint. In this case, SOLIDWORKS just interpolates in a linear fashion from a circle to a rectangle. But when I use the normal to profile, SOLIDWORKS begins to put a little bit of curvature on one end, and then if you apply it on both ends, normal to profile, you get a smooth S shape. Let's flip back to the assembly. Remember, Control-Tab accomplishes that. Click on this part in the graphics area. That calls it up in the feature manager, and we can open the part from there. The wishbone is also a relatively simple part. Let's roll this back and have a look. The first feature is the most difficult, although it's not very difficult at all. In fact, it's rather easy. The sweep was made from a U-shaped sketch and, in this case, a square. To get the feature to twist, we just used an option within the sweep itself. The profile is the square, the path is the U shape, and the special setting we used was twist along path. If we set this back to the default of follow path, we get the straight sweep that we're accustomed to seeing. This could have been easily created with an extrude. Twist along path allows you to define the twist in terms of degrees, radians, or turns. In this case, turns makes the most sense. The thin feature option allows us to create a hollowed out part all in one smooth feature. Having a twisted part like this that's hollowed out may or may not be realistic from a manufacturing standpoint. From here, an extrude was created, and this is not exactly straightforward, so let's take a look at how it was done. In several examples in this assembly, I've made use of the From panel in the Extrude Property Manager. What this means is that I can sketch on a completely different plane and then start the extrusion in some parallel but distant location. In this case, I started the extrusion almost 2 feet away from where the sketch started. From here, I was able to adjust the direction of the extrusion using the direction arrow and use the up to body end condition. In this case, the up to next was not available for some reason, so up to body works just as well, but when you specify up to body, you also have to select the specific body that you want to extrude up to. From here, the next feature created was a loft, and this loft was really just to finish off the twist at the end of the wishbone. If we take a look at this, on one end we have a rectangular shape, and on the other end we have a square shape, and so the loft feature allows us to transition between these rather smoothly. I've only used one optional setting in this, which was the tangency to face end constraint on the square end. So what this means is that as the loft comes off of the existing geometry, SOLIDWORKS makes the faces tangent to those existing faces. at the start of this feature, I used the normal to profile to make sure that this transitions smoothly into a straight extrude. From here, I added an extrude onto this end to mount the linkage and mirrored the feature to the other side. From here, a cut was added for the pivot hole and fillets were added to round out the edges.